what do we think? The electric field should point in what direction compared to the electron drift velocity? Opposite direction, right? Because these are electrons. The force is going to be in the opposite direction of the electric field. So E will be pointing that way. And what about the relative magnitudes of the electric field vectors? Should be the same everywhere, right? Because if we have the same drift speed from V equals UE, we should have the same electric field. So we have E pointing that way, and then that way here, and then that way here, and so on. Okay? So you end up with something that looks like that, right? You should have something like that on your diagram. Okay, so now here's the question. We know what it looks like in the steady state. But let's think about sort of the first instant after you connect the circuit together. So we're really going to be talking about what we called last time a transient situation, where we're going from equilibrium, where there's no current flowing, and eventually reaching a steady state. And that it happens almost instantaneously, but there is a small amount of time where things are changing. And so initially we have the charge on this battery, like two plates of a capacitor. It looks kind of like a dipole. We talked about that last time. So think about if we assume that initially the only charges are on the battery, they're the only ones here, what would the electric field look like at each of those locations? So on the bottom diagram, the second picture on the bottom, draw an arrow representing the electric field due only to the charges on the battery at each of those x's. Think about what the field due to that charge distribution would look like at each of those locations. It's okay to be wrong here. Let me emphasize this. It's actually useful to go through and expend the mental energy to try this out. Okay, again, just think of it as a dipole. Okay, you have a positive charge on one end, right? Negative on the other. How do we calculate the electric field, or at least just work out the directions of the electric field of a dipole on the axis and then on that perpendicular axis? In some way, we're sort of just ignoring the presence of the wire for just a second and just looking at those particular observation locations. So try it out.